we just finished up with area, so next we're going to talk about volume. Now, what you want to remember about volume is that we're in 3 dimensions here, so it's 3D. So if you have like a cube, for instance, okay, then what you're doing here is you have some sort of length, you have some sort of width, and you have some sort of height. So if you have a box shape, again, there's different volume formulas for different objects, but if you have a box shape, your volume is length times width times height. So what's happening is that we're getting 3 dimensions here. So let's say our length was 1 inch, our height was 1 inch, and our width was 1 inch. So you'd have 1 times 1 times 1, which is obviously 1. But then you'd also have an inch times an inch times an inch. So you're left with inch cubed. So we're dealing with cubic units here instead of squared units when we're talking about volume. So examples of things that have volume or in 3 dimension could be a shoebox, so it's similar to looking like this, or a basketball. Volume refers to the amount of space occupied by the figures. In order to measure the space, we deal with cubic units. We're going to see the following examples. Actually, let's do it on this page. I have some room on the page. All right, so I left a little bit of room here. We'll just do it here. So I kind of did the inch one already, but I'll blow it up a little bit bigger. And again, this is not to scale, but I'm making my cube. So as I said, if this was 1 inch, and this was 1 inch, and this was 1 inch, then our volume here is going to be 1 inch cubed. And you can do it different dimensions too. So let's say instead of doing inches, maybe I had centimeters. Maybe this is 1 centimeter by 1 centimeter by 1 centimeter tall. So you're looking at 1 times 1 times 1, but you're also cubing the centimeters. So you're getting cubic centimeters. So again, we're just using that little 3 now for our power to represent cubic units. So here's an example. This one I didn't want to draw out because it's a little bit more complicated. So looking for the volume of the figure, of the object shown in this figure here. So now you can see your cubic unit is an actual cube. It has 3 dimensions. So you can find volume by using a formula like we did with length times width times height for our rectangles, but you can also do it by counting the cubes. So for instance, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 cubes on top. Can everybody see the 9 cubes? But notice that I have 2 layers here. So there's going to be 9 cubes on top and 9 cubes on bottom. So you're going to see 18 cubes altogether. And you can see that a little bit better in this picture here. So they kind of like remove the first layer for you visually. So you can see the 1, 2, 3, 4, 5, 6, 7, 8, 9 on the bottom. And then again, another 9 on top to get 18. So with the 3D images, it's a little bit harder to see. So I would try to count maybe the top and then think about how many layers you have and know that those layers repeat down. So I have 9 units on top, but I have 2 layers. So 9 times 2 is going to give me the 18 cubic units here. Okay. Now again, here's some helpful conversions that we're going to be using. These are English conversions again. So 2 pints is the same as 1 quart. 4 quarts is the same as 1 gallon. 1 gallon is the same as 128 fluid ounces. And again, you have all your abbreviations here. And 1 cup is the same thing as 8 fluid ounces. When we're talking about volume compared to capacity, again, 1 cubic yard is about 200 gallons. 1 cubic foot is about 7.48 gallons. And 230 cubic inches refers to about 1 gallon. So again, these are just some conversions that we're going to be using in class, and I would recommend just kind of keeping a running tally so you have them easily accessible. So let's say a swimming pool has a volume of 22,500 cubic feet. We want to know how many gallons the pool holds, and we're going to use dimensional analysis. So unless you're within the metric system, everything else is probably going to be dimensional analysis. So I want to get rid of that cubic feet, and I want to go to gallons. So let's see if I have a conversion for that. I do right here. So 1 cubic foot is about 7.48 gallons. So 1 cubic foot is about 7.48 gallons. So our units will cancel. And then in the bottom, you're just dividing by 1, so that's not really going to change anything. And then you're looking at 22,500 times 7.48 gallons. So let's see, when you multiply that out, you get 168,300 gallons. Now, as we've come to expect, things are much simpler in the metric system, because again, you're going by powers of 10. Now, for capacity, the basic unit is the liter in the metric system. It's kind of easy to remember because you have the meter and then you have the liter. So those tend to be the two main ones that we use a lot in the metric system. The liter happens to be slightly bigger than a quart. So just to kind of put it into the English system, 1 liter is about 1.0567 quarts. So they're almost the same size. Just like before, kilo means 1,000, hecto means 100, and so on. So you have very similar notation to what we had with the meters. So instead of being kilometers, it's kiloliters. So you have that KL instead. Instead of hectom, what were we doing, hectometers before? Then we're doing hectoliters this time. So it's the same kind of prefixes, just a different base. So here we're doing liters. And again, just some ideas here. So just to have you have a better understanding. So a cup of coffee is about 250 milliliters. A 12-ounce can of soda is 355 milliliters. So just to kind of get an idea. A couple other important things to note here too. So, and you can see the figure over here. So 1 liter container is filled with water in the figure. And the water in the liter container will fit exactly into the cube shown on the right. So these are what this amount of water fits into here. So what we're saying is that the volume of this cube is 1,000 cubic centimeters or 1 cubic decimeter. So you do have another conversion here. So 1,000 cubic centimeters is the same thing as 1 cubic decimeter, which is the same thing as 1 liter. Okay, and again, another table to keep in mind. So 1 cubic centimeter is the same as 1 milliliter. 1 cubic decimeter or 1,000 cubic centimeters is the same as 1 liter. And 1 meter cubed, so 1 cubic meter is the same thing as 1 kiloliter. So you have quite a lot of conversions again to kind of keep track of. So let's say we're starting with an aquarium that has 36,000 cubic centimeters, and we want to know how many liters of water does the aquarium hold. So we have 36,000 cubic centimeters, and we want to go to liters here. So I do have a conversion. It's maybe not as obvious to see, but it's right here. 1,000 cubic centimeters is the same thing as 1 liter. So 1 liter to 1,000 cubic centimeters. So these are going to cancel. 36,000 times 1 is just 36,000. And we're dividing by 1,000 here. So our answer is going to be 36. Okay. A couple more examples, or one more example really, with volume. All right, so volume is actually used a lot with medication too. So if there's anyone in the medical field, you're going to be dealing a lot of times with milliliters in your dosages. Although when we go home to give our kids medicine or take medicine, a lot of times it'll say to use a teaspoon. They'll give you like kind of both conversions, the teaspoon and the milliliters. So it's helpful to know how to go back and forth here as well. So again, you have your English to metric conversions, which particularly is helpful with medication. So one other thing to note here is that 1 cubic centimeter is the same thing as 1 milliliter as well, which was on the previous page, I believe, as well. Let's see. Yeah, it was in our previous chart too. So again, just some things to keep in mind here. Dosages, excuse me, of liquid medication are measured using cubic centimeters or milliliters, as they're also called. And the United States they use cc rather than cubic centimeter sometimes. So you may see that interchange between the two. So just kind of a quick note there that sometimes I'll use cc's instead of the cubic centimeters. So a physician orders 10 cc's of the drug Lexapro, which is used to treat depression and anxiety, to be administered to a patient in liquid form. How many milliliters of the drug should be administered? So we're starting with 10 cc's, and we want to figure out how many milliliters this is going to convert to. Now, remember cc's, and this is going to be important here. So cc's is the same thing as cubic centimeters. So I'm going to just rewrite this before I start, because I do have a conversion here for cubic centimeters to milliliters. It's a one-to-one conversion, which makes it really easy. So I have 10 cubic centimeters, and we're going to milliliters. And like I said, it's a one-to-one conversion. So you're going to get 10 milliliters here. Of Lexapro. Now for B, they want us to figure out how many fluid ounces this happens to be. So again, I'm going to go up here, and I do see I have a conversion for fluid ounces with milliliters. So that's good. So I can make it a one-step conversion here. So I'm starting with 10 milliliters, and I want to go to fluid ounces. And I see the conversion is 1 fluid ounce is 30 milliliters. So 1 fluid ounce is 30 milliliters. So 10 times 1 is 10. Milliliters are going to cancel. And this actually can simplify, right? I can cancel my zeros here, so I end up with 1/3 of a fluid ounce as my answer, which is about 0.33 fluid ounces if you use your calculator and you round there. So we can convert to ounces here as well.